Myself, Naveen Reddy. This session is totally for the students who belongs to BScIT 6 Sem of Mumbai University. See, when you talk about 6 Sem, you have different subjects like you have IT, you have data warehouse, you have project management, you have DSS. Now we will focus on a subject called as DSS, which stands for the Digital Signals and System. See, this session is just an introduction to what is exactly DSS. Because see, when you talk about different subjects, like when you talk about IT, it makes sense that you belongs to BScIT and you have a subject called as Internet Technology. So it makes sense. When you talk about data warehouse, it makes sense again because you belongs to IT, you work with data and you work with huge sum of data, so you require something called as data warehouse. Again, it makes sense when you talk about IT, you have to manage some projects. So a person who is managing a project called as project manager. So if you want to define the roles of project manager, you require a project management. You have one more thing called as project. Obvious things is, if you learn so much of things in your 6 Sems, you have to implement those concepts in something that is your project. But question arises when you hear a subject name as Digital Signals and Systems. See, lots of people think, when you talk about digital DSS subject, it belongs to engineering. No, it belongs to IT. Let me prove it. See, when you talk about data, in computers, when you talk about data are stored in 1 and 0. The reason behind when you talk about 0 and 1, it is called as binary language. Computer only understand 0 and 1. The basic reason behind it is, when you talk about computers, it is an electronic machine. And when you talk about electronic machine, it works with electronic signals. And that electronic signals work in it's on, it's off. So when you try to represent it is on, you say 1. When you say it is off, you say 0. So in simple terms, in electrical signals or in computer also, you work with signals. It can be signal on, it can be signal off. So that means in computer, you deals with signals. Let's go more ahead. So when you talk about telecalling or you call someone, you say something, other person hears something. How is it possible? Because when you say something, your mobile device is emitting some radiations or some signals. These signals are transferred to that device and you are able to talk. That means again you have signals. Now there is a concept called as, you can log in into some system by using your face. If you want to log in into your laptop, you can show your face and using your face, you can get a login. How is it possible? Here the concept comes is image processing. You have your face here. This is an image. This image will be processed so that you can be logged in. Example, this image will be stored in your laptop, and when a person try to log in, they will compare the current image and the image which is saved. So when you compare this image, you have there's some technical problem. Avoid it. So when you compare this image, you have inbuilt image and you have the current image. When you compare this image, you will get a login. Now question arises, how can you compare two images? See, when you try to compare two images, we have to process both the images. And when you talk about processing of image, it is called as image processing. And again, when you talk about image processing, it's a concept of IT. And for image processing, you require something called as Digital Signal and Systems. Let's move ahead. When you talk about Google, when you talk about Google has something called as voice recognition. You can search anything on Google by your voice. If you have your fingers sculpted or you have a hurt on your finger, so you cannot type it. So what you can do it, you can press a long press on your button. If you are using an Android phone, you can talk. If you speak, you will get some results. Example, if you want to search about Java on internet, you can just say Java. It will automatically search. A question arises, you are speaking something and you are getting a text. Again, it is done by signals. So in short, you are doing everything with signals. So IT is depend upon signals. Again, when you talk about humans also, if you are living in India, cricket is a decision in India. And when you say, this thing, I don't have to say this is 4, because when I give a gesture this way, it is called as 4 or boundary. When I say this is 6. When I say this is out. We have certain signals. When umpire works on field, he works with some signals. In the same way, when you talk about computers, everything works with signals. Now when you talk about these signals are of two types. One is analog signals, second is digital signals. So you have two types. One is analog, second is digital. Now till now we are using, till last generation we were dealing with analog signals. Now we are dealing with digital signals. That means we have a generation ahead which works with digital signals. From analog signals we have jumped onto digital signals. And your subject is totally dependent upon this digital signals. Therefore the subject name is Digital Signals and System. And the book you require to learn is this one. When you talk about your digital signals and systems, you have this book, something called as Digital Signals and Processing. You have this book. This is an Indian publication book, local publication book. Tata McGraw. It's not local, it's international. Tata McGraw. But the authors are Indians. So it's much easier to learn this book. And the advantage of learning this book is it's pretty easy. Second, you have lots of mathematical calculations. Then this book is made up by these people by their notes. They give lecture internationally and they prepare their own notes. So they prepare this book by their own notes. Now, what are the drawbacks of this book? This book. Now, this book has lots of calculations, lots of mathematical derivations. When you typically say this book, it has lots of formulas, lots of derivations, lots of theorem. In other, if you say in different way, you will see this is not a DSS book, this is a maths book, because you have lots of calculations. But the thing is, when you talk about signals are mathematical functions. If you try to give me a function of f of x, in mathematics we call it as functions, in technical way we call it as signals. So any signals we can represent in the form of f of x. Not just f of x, any functions with some parameter. Example, this function totally depends upon x. You have a variable called as x. So maybe when you talk about signals, it can be x of t. So when you talk about x of t, it is x function on t, where t is your time. So that means you have some signals, you have some functions. So indirectly, this book deals with lots of calculations. So if you want to score at least 60, you have to be very clear with your mathematical concepts. So if you find mathematics very difficult, you have only one option. That is, go to your 12th standard books, learn about all the formulas like derivatives, like integrations. In fact, last year, in second year you will be having something called as maths, in which you will be having Laplace transformation. You require Laplace transformation when you learn this book. So your basics should be clear, your physics should be clear, so that you can learn this subject very thoroughly. Again, this is not a tough subject, this is very easy. You have limited amount of syllabus. You don't have the whole book, you just have the 8 chapters of this. So it's not a huge syllabus, but every topic is pretty difficult if you don't have the basics of maths and physics. Again, when you talk about physics, I am talking about that signals. When you talk about these signals, you have line signals, you have different type of signals. So when I say physics, it is signals. When I talk about maths, it is that formulas, derivatives, integrations and Laplace. So there is nothing to worry. So let's start with something on the DSS. So here, when you talk about DSS, this book deals with digital signal processing. So we will term it as DSP, not DSS. So it is DSP, Digital Signal Processing. Now we have analog, we have digital. Question arises, if we have analog signals, why should we process something in digital? The answer is, when you talk about analog signals, it has high range of values. If you get any noise, example, I am speaking to you and I am banging something, this is called as noise. I am speaking also, I am banging also. You have two voices. At the same time, you get irritated because you have two voices. If I speak in this way, If I speak louder and I have a small noise, it doesn't make sense. If I have small noise and big bang, like I'm talking something and you have the big bang, so it matters. When I speak, I'm giving you some signals. When I bang, it's generating some signals. So it generates some signals, I'm speaking some signals. When these signals collide, it creates noise. So in short, if you want to clear the noise in DSS, when you go for the digital signals, you can remove the noise very easily. Second thing, when you talk about analog signals, you have high range of values. It can be 1 to infinity. But when you talk about digital signals, digital signals works with 0 and 1. So pretty easy to remove noise. You can remove your original signals. So it's pretty easy when you go for digital signals. Now, so when you talk about applications, digital signals used normally in military. It can be used in image processing. Military. When you talk about military, it is you can radars work with signals, sonar signals. So you have different signals in military also. When you talk about IT, you deals with image processing. You deals with speech. So it all works with signals. In health industry also, when you go for MRI scan, you go for CT scan. It all works with signals. Okay. Now, if you have seen movies, lots of movies has some, a patient is lying on ICU bed and is attached with a machine where it detects the heartbeat. So you have a signals there. So if signals is banging or it's changing, he's alive. If you are getting the land signal, he's dead. Again, it works with signals. Now, when you talk about types of signals, you have two types of signals. So types of signal. One type of signal is continuous. Second type of signal is discrete. Now it is very easy to understand these two terms. One is continuous, second is discrete. Now when you talk about continuous signal, if you get a signal in this way, you have a line of T, this is your time, a starting point, ending point, so this is your T. Now if you get a signal in this way, this is called as continuous signal. Why? Now, if I want to get the value of this signal at this point, I can get, if the value of signal at this point is this. So I can get the value. If I want to get the value of T or a signal at point this, I can get a point by this. Because you will get any point at any time, it is called as continuous signal. You get all the values continuously. But when we talk about discrete signal, it works in different way. Discrete signals works with values, not time. If you have this value, these are the discrete signals. You can represent discrete signal in this way. Now, if you try to judge the signal, this goes in this way. You can assume this goes in this way. You cannot say this goes in this way. You can assume. You just have the waves. You can have the virtual thought about it, but physically you cannot get a value if your position is this. You can get the value of this point in the location this point. You cannot get a value if you want to get a value of this point, because this is not a continuous signal. This is discrete signal, this is continuous signal. Now continuous signals works with time, discrete signal work with samples, something called as N. This is your first sample, this is your second sample, this is your third sample, fourth sample, fifth sample. And when you talk about the number of samples, it is almost 8 samples. So the value of N here is 8. So you have number of samples. This is time, this is samples, represented by T, represented by N. So you have two types of signal, one is continuous, second is discrete. Now let's focus on discrete signal, because see, when you talk about processing, normally the word processing comes when you talk about you have limited number of values. If you talk about continuous signal, you have huge number of values, and if you have to try to calculate, it's pretty difficult to calculate things in continuous signal. So if you get a discrete signals, you will be having a finite number of values. You can you can do the processing part. But when you focus on discrete signal, again this discrete signals has different types, different sequence. When you talk about the first type of discrete signal is your unit impulse. Now unit impulse is very easy. Like if you get a sound in this way, you're getting the values, all values. You have very quiet environment. Nothing is happening. Everything is quiet. Let's suppose. Let me be quiet for 2 seconds or 3 seconds. Something clicks. When you have the zero, you have the line of zero. Suddenly you get a sound. When you get a sound, this is a sudden sound. You get a sudden impulse and you get down. That means you have the line. This is your -3, -2, -1, 0. It's your 1, it's 2, it's 3. So when you talk about this line here, till this point everything is silent. You don't have any sound. Suddenly at this point you're getting an impulse. Suddenly you're getting a sound. Till here you don't have any sound. Suddenly at this point you're getting a bang. When you get this bang, this is a sudden impulse. Again after bang, you're getting a low signal. You're getting all the values of 0. Now this unit impulse is represented by delta. Now if you are going for continuous signals, this is represented by t. So delta t. The value of delta t will be 1 when your t will be 0, because when you have t0 you have the impulse of 1. It will be 0 if your t is not equal to 0, as simple as that, because everywhere it is 0. Only at 0 point you are getting the impulse. This is unit impulse. Now second type of thing is something called as unit step. So you have unit step. Now if you integrate all the impulse, you're getting the bang once. So this is one bang, this is second bang, this is third bang, this is fourth bang. When you combine all the bangs, like example you have -2, -1 and 0. This is your 1, this is your 2, this is your 3. After this start, when you get 0, after every second you are getting a bang, 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 bang. That means here you are getting the impulse, you are getting the impulse, you are getting the impulse, you are getting the impulse. That means you have here the sudden step. Till here you are getting 0, suddenly here you are getting a step. This is called as unit step. That means unit step will be, if you integrate, if you integrate all your data t, you will get a step function, and that is your value will be 1. This can be represented by u of t. U represents unit step and t is your with time. This is unit step. Next one is something called as unit ramp. When you get sudden, step by step. Example, when I bang once, bang, 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 bang. Now I am suddenly increasing this sound. That means start it was low. After 1 second or a period of time, it is getting the sound double. Then sound increase, then sound increase. With time, this sound is continuously increasing. This is called as unit ramp. So next is unit ramp. Unit ramp means you are getting your sound continuously increasing. At time 0 it was 0. At time 1 you are getting a sound bit. At time 2 you are getting increased sound. At time 3 getting increased sound. So this is you are increasing your sound. And when you talk about the slope of this will be 1. So this is ramp. You are continuously increasing your size. So at start it will be a low value. After 1 second or 1 period of time it will get a high value. Again high volume you will get a unit ramp. In second terms, when you integrate all your unit step, you will get a ramp function. What is integration? Unit step? It is integration of delta t. So in other terms we can say integration of unit impulse is unit step, integration of unit step is unit ramp. So indirectly double integration of unit impulse is you can get unit ramp. Okay. Next is unit pulse. Now when you talk about unit pulse, now unit pulse is much easier. You are getting a line. You have 0, you have 1, you have 2, you have, sorry, this is -1, -2, you have your 1 and 2. Suddenly at this point you are getting a bang. This time it is not a single impulse. This is multiple impulse of some amplitude. The area of this amplitude will be 1. So if you have the low time, high amplitude, it will be 1. So what if I increase the time? You know, you are started here, you are ended here, with a sound. If I want to reduce the time, I have to increase the amplitude. So, or in different way, if I have to reduce the time or increase the time, I have to reduce the amplitude. If I start here, end here. So I am getting a line, but here the amplitude will be reduced because I want to again cover the area of 1. So time decreases, amplitude increases, time increases, amplitude decreases, the overall value will be 1. Therefore it is called as unit pulse. You know, we have seen the 4 different type of discrete signals or sequence. One is unit impulse, unit step, unit ramp and unit pulse. We will see the further session in the next video. Thanks for watching. That's it.